For this next tutorial, we're going to be naming alkynes. If you already saw the video on naming alkenes, this should be a breeze. First of all, off the bat, cis and trans do not apply at all for alkynes. So don't be fooled, because sometimes teachers, we love to make trouble for you guys to give you trick exercises. So even if the molecule seems like it's cis or trans, it's not. Because remember, triple bonds are non-rotate. They rotate, but they don't form those shapes. So how can you encounter these type of exercises? I'm going to draw a straight line. It really depends on the book you're looking at. And for example, here, how many carbon atoms do we have? 1, 2, 3, 4. But some books or other people, you can draw them like this. And this is where we get into trouble with cis or trans, okay? Because you might use other types of paper that make you think that this is cis or trans. However, remember, triple bonds only have a 180-degree angle, so this is just an issue with representation. But don't be fooled, it's very simple. Again, just like with double bonds, triple bonds are the star of the show, so we want to give it the lowest numbers possible. So right here, if I take this molecule, it's going to be 1, 2, 3, 4, and I only indicate where that triple bond is. 4 carbons, but. Ending of alkynes, ine, butyne. Where is my triple bond? It's located at carbon number 2, 2-butyne. What happens if we want to draw 1-butyne? Same thing. I just draw my 4 carbons, 1, 2, 3, 4, and at number 1, I draw my triple bond, 1-butyne. Very simple. This one is also what? 2-butyne, because it's at number 2. This is also 2-butyne, because remember, there's no cis or trans for alkynes. Same thing, if we draw a more complicated example, we can have 7, and I draw this, and I draw this. It's another multiple exercise. How many carbons do we have? We have 7, so we're at hepta. How many triple bonds do we have? 2 triple bonds, so we're going to write di. What is the ending for alkynes? Ine. So hepta, di, ine. Where are those triple bonds located? If I start on this side, 1, 2, 3, at 3, 4, 5, 6. But we want the lowest numbers because the triple bond is the star of the show. So I'm going to write 1, 2, 3, 4, 5, 6, 7. I always recommend that you write the little numbers because that helps you keep track. It's a lot of things to analyze. So in this sense, we just write 1, comma, 4, dash heptadiene, and that's it. It's very simple. Now, just like with alkenes, you can get more complicated examples, but it doesn't really matter. What you guys want to do is analyze who has a priority. So let's draw a really long chain, and I'm going to draw substituents over here, and then I'm going to write my triple bond here, and I'm going to write fluorine here. So we're complicating things a little bit, but it's really all the same thing. Longest chain, and then who's the star of the show? The triple bond. Who gets the lowest numbers? It doesn't matter if over here we have number 2, because the star of the show is a triple bond. So we need to give that triple bond my lowest numbers, and that really simplifies things. So I'm going to write 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This means that there's 10 carbon atoms with one triple bond, I'm sorry. So I'm going to write dec. And then the ending for alkynes is ine, decyne, or decyne, depending on how you pronounce it. And it's at number 3, decyne. Then we highlight everything else that's left over, which is my fluorine atom. And then we have 2 carbon atoms attached there. So this is fluoro. This is methyl. What comes first alphabetically? Fluoro. And with its locant, 7 fluoro. And then 9, 9 dimethyl, because we have 2 different methyl groups. That's why we write di, and they're both attached at the 9th carbon. 7 fluoro, 9 dimethyl, 3 decyne or decyne. Remember, the triple bond is the star of the show, just like the double bond was for alkenes. And make sure you keep this in mind for every other chemical family when you have a more important functional group.